Hey, welcome back to my channel. Today I'm going to talk about the periodic table, the ultimate chemistry cheat sheet for understanding the elements that make up everything, including you. Whether you're heading for a career in the health sciences or you're just trying to survive your first general chemistry class, this video will help you unlock the way, the why, and the how behind the periodic table. So if you're looking at a saline solution in IV bags, maybe the oxygen in your lungs and how it interacts with iron, chemistry is pretty much everywhere in healthcare. In a periodic table, this is your map to understanding it all, right? Now how do we read it? So let's rewind, let's go back to 1869. That's when a brilliant Russian scientist named Dmitry Mendeleev noticed something fascinating. When he arranged the elements by increasing atomic mass, interesting patterns started to emerge. He was so confident in these patterns that he left blank spaces for elements that hadn't even been discovered yet. And he predicted their properties. And of course, yes, he was right. That's how the periodic table earned its nickname, the chemist's crystal ball. Mendeleev's first periodic table, published in 1869, organized the 63 known chemical elements at the time by their atomic weight and chemical properties. Today, there's 118 known chemical elements organized in a similar fashion. So now let's decode this table. The rows, up and down, the rows that's side by side, these are called periods. Each new period adds another layer or shell of electrons. The columns are called groups or families. And this is where all the magic happens. Why? Because elements in the same group have the same number of valence electrons. These are bonding electrons. That's the outermost electrons that are responsible for bonding to other chemical elements. So that means group 1, like sodium, these elements are like sodium, potassium, they all form +1 ions. Group 2 elements such as beryllium and magnesium, they like to form +2 ions. And on the other side of the periodic table, we have group 17. Those are called the halogen elements. They like to form -1 ions. And so that's huge for predicting how compounds like sodium chloride, table salt, or potassium chloride, which is used in IVs, form. Chemistry also has style, and that's called the S, P, D, and F blocks. These blocks tell us where the last electron of each element lives, in which orbital type. So the S block is groups 1 and 2 plus helium. These are your alkali and alkaline earth metals. They're very reactive. They're also pretty common in biology, mainly as electrolytes. The P block, this is groups 13 to 18. That's home to the nonmetals, the metalloids, as well as the noble gases. Think atoms like oxygen, carbon, nitrogen. These are the building blocks of proteins and most living organisms. The D block is that big middle section. These are called the transition metals. These include metals like iron, copper, even metals like platinum, gold, and silver as well. A lot of these are vital in enzymes, blood, and other functions in life too. And then the F block is the bottom row. That looks kind of like a footnote. These are the lanthanides and actinides, and they have very unique uses in medicine and imaging as well. So do you want to know what elements will bond and how? Here's where you're going to use the group numbers and the electron configurations. And the goal here is to add up to the atoms, the noble gas configuration. Group 1 elements will lose 1 electron to get to their noble gas configuration. They'll typically form +1 ions. Group 2 loses 2 electrons. They'll form +2 ions. Group 16, of course, gains 2 electrons. They could form -2 ions. And group 17 will gain 1 electron, forming -1 ions. In order to get, again, you want to get to the noble gas configuration of electrons. So these charge patterns help you predict ion compounds like calcium chloride, CaCl2, or magnesium sulfate, MgSO4. These are commonly used in healthcare. Now, in the latter half of the 20th century, several circular or spiral designs of the periodic table were designed, arranging the chemical elements in a spiral pattern instead of the traditional grid that's seen in many classrooms. This highlights the relationships and trends between elements more clearly. This sculpture here, hanging in the south atrium of the Laboratory of Science Commons here at Tennessee Tech University, depicts a spiral periodic table with atoms of the chemical elements. The nucleus is modeled in colorful dichroic glass, showing the atomic number, and the electrons are shown according to their energy levels in the Bohr model of the atom. The sculpture was completed in 2022 by California-based artist Roger Berry. Now let's look at some interesting and trivial facts about the periodic table. First, the only letters that are not used in the chemical element symbols in the periodic table are Q and J. So there's no God element in the periodic table, Jehovah. But remember, Dr. Jones reminded us that in Latin, Jehovah is spelled with an I, so you could make God that way. There's also 5 elements named after nations: francium, France; polonium, Poland; germanium, Germany; neonium, Japan; and ruthenium, Russia. There's no element named after the United States, but americium is named after the Americas, North and South, and 2 U.S. states have elements named after them. That's Californium and Tennessee. Did you know the element francium is so rare that less than 30 grams of it are present on Earth at any given time? And technetium was also the first element to be made artificially, and today it's commonly used in medical imaging such as CT scans and X-rays. It's also produced, technetium is produced in nuclear power plants. It's also the latest element on the periodic table that only holds unstable radioactive elements. Today there's actually 20 known artificial elements on the periodic table, and then the other 98 are all found in nature. The process of nuclear fusion that occurs in stars such as the Sun produces all of the elements from helium, atomic number 2, up to iron, atomic number 26. And then supernova can produce many of the heavier elements beyond that. Of course, so far the Sun has not gone supernova yet. Thank God. So, while there's currently 118 known chemical elements on the periodic table, there could be more. Scientists are working on synthesizing heavier elements, and then they will add them to a new 8th row, at the bottom of the periodic table when they're discovered. However, there likely will never be any elements beyond 137 added to the periodic table. This is due to relativistic effects. What does that mean? So, as atomic numbers increase, the innermost electron speeds would approach or exceed the speed of light. And if they exceed the speed of light, that would violate Einstein's theory of special relativity. That's because as the number of protons, which is also the atomic number, in the nucleus increases, the nucleus becomes more positively charged. This exerts a stronger attractive force on the electrons. This increased attraction causes the innermost electrons to orbit the nucleus at higher speeds. According to Einstein's theory of special relativity, nothing can travel faster than light. If the atomic number were to increase beyond 137, the innermost electrons would theoretically need to travel faster than light in order to remain in their orbitals. And of course, that would violate relativity. This was proposed in the 1960s by the theoretical physicist Richard Feynman. He's the one who suggested that an element with 137 protons would be at this limit, and beyond that, it would violate relativity, right? More recent research actually suggests this limit might actually be closer to 173, since the nucleus is not really a point mass and actually has a size and shape. This would affect the electron's motion as well as the speed at which they must orbit. The good news here is that in the health sciences, we rarely get below the third or the fourth periods. The 6 most common chemical elements found in living organisms are hydrogen, carbon, nitrogen, oxygen, phosphorus, and sulfur. I kind of like to rearrange these in order to spell out schnapps, just to make it a little bit easier to remember. There's also a lot of other chemical elements in living organisms, and not just 6, that are important for life. And for example, you should be aware of how electrolytes behave in the body, right? The electrolytes are ionic elements with a +1, a -1, or a +2 charge. These could be sodium, magnesium, potassium, calcium, and chloride. They're also important, but also keep in mind that potassium, while it's important in the body, if it's in too high levels, that could actually be fairly dangerous. And so potassium overdose could be a medical thing that you would actually see if you're working in a hospital situation. You also can't breathe if you didn't have iron in your blood, and cobalt is also a very important metal and a transition metal as well that's present in cobalamin. That's vitamin B12. Vitamin B12 is a vital cofactor in DNA synthesis and plays a role in fatty acid and amino acid metabolism. It's also important in myelin synthesis in the nervous system and the maturation of red blood cells in bone marrow. Below the 4th period, elements mostly tend to be radioactive and poisonous to living organisms. So this includes elements such as mercury, that's atomic number 80, lead, atomic number 82, polonium, 84, radium, 88, and even elements like uranium, which is atomic number 92, and plutonium, atomic number 94, could be used to make powerful bombs to destroy life as we know it. Remember the quote from the Hindu scripture Bhagavad Gita, spoken by J. Robert Oppenheimer, reflecting on the Trinity test. Now I am become death, the destroyer of worlds. But there are some useful elements down in the lower part of the periodic table. Barium, atomic number 56, makes barium sulfate, and this is a radiopaque contrast agent that's used in medical imaging, such as X-rays and CT scans, similar to technetium. This is really useful in visualizing the GI tract. So if you have a disorder of the gastrointestinal tract, you may take a barium enema. Platinum 78 and gold atomic number 79 are also used to make various drugs for the treatment of cancer and rheumatoid arthritis. These drugs include cisplatin, myocristin, and auranofin. Americium atomic number 95 is also commonly found in household smoke detectors. So the periodic table is your starting point when referring to all of the important elements for living organisms. Hopefully now you realize the periodic table is not just a wall chart, it's a vital reference for everything important in chemistry. But please don't memorize it. It's available in every classroom, and simple rote memorization of the chemical elements and where they are is really not going to do you any good. It probably will just frustrate you to no end. You do want to remember how it is organized and how to use it to predict element properties and how to make compounds. So I hope you found this video helpful. Go ahead and hit the like and the subscribe button below to stay informed of new content on this channel. And of course, if you have any additional questions or you want to share something useful or some interesting trivia on the periodic table, go ahead and leave a comment below. I like to read these, and it kind of helps me see how people are using my videos and watching some of the useful information. And I'll see you in the next video. Thank you and have a nice day.